Hello there, and welcome to this video on radical equations. So we're going to be going through some different examples, we're going to be solving them, and we're also going to be stating our restrictions, because anytime you have a radical, you need to state the restrictions. So our steps, number one, we're going to state restrictions. We do that first just to get it out of the way so we don't forget to do it later. Step two, you're going to isolate the radical. So isolate just means get it by itself, so get this by itself. Step three, you'll square both sides of the equation. It's got to be both sides of the equation so that the equation still remains equal. And what that squaring does is it's going to get rid of the square root. And then step four, solve algebraically and check for extraneous roots. So extraneous roots, all those are solutions that you get that actually don't work. So when you plug it back into the equation, if you plugged it in here, you're not going to get out, say, 10. Okay, so looking at number one, what we're going to do is first the restrictions. I'm just going to use RESTR to represent my restrictions. So this radical here, that has to be restricted. So anything inside of the square root needs to be non-negative. Okay, so we're going to say 2x minus 1 has to be greater than or equal to 0. And then we'll solve that. So add a 1 onto both sides. And then those will cancel and you'll just have 2x is greater than 1. And then divide both sides by 2. So you get x is greater than or equal to 1 over 2. So we're done the restriction. So if I don't get an answer that is greater than or equal to 1 over 2, a half, like if I got something negative or just less than a half, I know it's not going to be correct. So let's actually start to solve this now. So step two, isolate the radical. So we got to get this radical by itself. So let's minus this 3 to get rid of the 3. And then I'm going to have 2x minus 1 in the square root equals 10 minus 3 is 7. So we're done step two. Step three, square both sides of the equation. So I'm going to square this and then square this. The square and the square root cancel. So we're just left with 2x minus 1 equals 7 squared is 49. And then we're going to move on to step four, solve algebraically. So just isolate x, get it by itself. So I'm going to have to add 1 onto both sides. The 1's will cancel. And then I have 2x equals 50. And then divide both sides by a 2. So we're going to get x equals 25. So to verify our answer here now, because we want to make sure that that value x equals 25 actually works, we're just going to plug it in. So I got 3 plus the square root of 2 times x, and x is 25, and then minus 1. Then we got to simplify this, and we should get out a 10. So 3 plus 2 times 25 is 50, minus 1 is 49, so I got the square root of 49. And then 3 plus square root 49, square root 49 is just 7, and 3 plus 7 is 10. So I did get 10. That is what we had over here in the original one. So x equals 25 is the correct answer. Looking at number two here now. So we're going to do our restrictions here first on the left. So the square root, 5 minus n, that has to be greater than or equal to 0 because this is a square root. And then we're going to solve that. So subtract 5 from both sides. So we got negative 5 over here now. And then divide both sides by a negative 1. And when you divide by a negative 1, these are going to cancel, but also this inequality here, that is going to flip. So I'm going to get n is less than or equal to, and then those two negatives will also cancel, and we get 5. So n is less than or equal to 5. Now for the solving, we're going to get the radical by itself, so we're going to have to minus n from both sides first. So I'm going to have minus 5 minus n in a square root equals negative 7 minus n. And then we want to get rid of this negative here, so we can divide both sides by a negative 1. That's going to give us 5 minus n equals, and then dividing this whole side by negative 1, it'll just change the sign, so I'll have a positive 7 plus n. Then we got a square to get rid of the square root. Got to do it on both sides. Square and square root cancel out, and I get 5 minus n equals, and then 7 plus n squared is 7 plus n times 7 plus n, and then we're going to have to FOIL that all out. So we'll do that in our next step just up here. So we got 5 minus n equals, when I FOIL that out, I'm going to get n squared plus 14n plus 49. And then to solve this, we're going to move everything all onto the same side. So I'm going to add an n onto both sides to get rid of this n. And I'm also going to subtract a 5 from both sides to get rid of that 5. So I got 0 equals n squared plus 15n plus 44. And then with this, what we want to do is our product and our sum. We want to factor that. So the product is 44. And the sum is 15, and we want to find two numbers that multiply to 44 and sum up to 15, and those two numbers are a 4 and an 11. So we're going to get n plus 4 in brackets times n plus 11, and then you'll take each of those, this one and this, set them equal to 0 and solve those. So you're going to get n equals negative 4 and negative 11. The last step here now would be to verify. So we want to take both of these answers and plug them back in and see if we actually get out what we should. So I'm going to check this negative 11 here. So I'm going to do that just right here. So I had n, I'm looking at this right here, so n minus, and n is now a negative 11, so negative 11 minus, and then the square root of 5 minus negative 11, and this should equal out a negative 7 when I'm done. So simplifying this, I got negative 11 minus, and then inside my radical, 5 minus a negative 11 is going to equal 16, and then negative 11 minus the square root of 16, that's a 4, and when I put those together, I get negative 15, and that is not what we were supposed to get out. We were supposed to get out a negative 7. So that one is actually extraneous, so we have to get rid of that one. So we got to say extraneous. If you would do the same thing and check the negative 4, that one actually works out. So the only answer to this is n equals negative 4. Moving to the next thing here, and these ones are going to be a little bit more difficult because there's going to be two radical terms. So step 1 is still going to be the same. We're going to state restrictions. Step 2, we're going to put one radical on one side and one on the other side. So that's where it gets a little bit different. And then what we do is we square both sides, and then after that we're going to simplify. If there's still a radical, we're going to have to square it again to get rid of that radical. And then step 5, exact same as before, we're just going to solve it and then check for extraneous roots. So let's start with this number 1 here first. We're going to do our restrictions. And we got two radicals, so we're going to have to do two different restrictions over here on the left. So I'm going to have x minus 1, that has to be greater than or equal to 0. And then I'm also going to have 5 minus x, that has to be greater than or equal to 0. So let's do the top one there. I'm going to add 1 onto both sides, and I get x is greater than or equal to 1. And then with the bottom one, I'm going to have to subtract 5 from both sides. So then this 5 is going to be over here now, and it's a negative 5. And then divide both sides by a negative 1, and we get x. And then remember, this inequality flips, and then that goes to positive. So this one was essentially the exact same as what we did here. It's just this had n, and now we had x. So if I wanted to then combine these two restrictions and put them together, I can do that, because I know x has to be greater than or equal to 1. So I'm going to say x has to be greater than or equal to 1. And x had to be less than or equal to 5. So here we'll put x is less than or equal to 5, and now we've combined it into one single inequality for the restrictions. Okay, so this would be a lot simpler than having two things, and it means essentially the same thing. So I'm just going to erase that now just so that I got room to solve this. So what we needed to do first when we're solving is we need to put a radical on each side. That was our step 2 here. we already have a radical on each side though. We got one here and we got one here. So I'm already done that. Then I want to do my next step where I square both sides. So I'm going to square these, and then the square and the square root is going to cancel on both of them. So what I get out is actually something quite simple. And now that I have that, now I can solve this. So we'll move all of the x's onto one side. So I'm going to add x onto here, add x there. These will cancel out. So I have two x's here. And I'm also going to add a 1 here and add a 1 here to get rid of those 1's. So I got 2x equals 6. And then I can just divide both sides by a 2, and I get x equals a 3. And then if you wanted to verify that, you just plug it back in, and in this case, this one checks out. X equals 3 is the only answer. So moving to our last example here now, we're first going to do those restrictions. So we have 4n plus 5, that's in a square root, so that has to be greater than or equal to 0. So I'll subtract 5 from both sides. We get that, and then divide both sides by a 4, and we get this. Then we can't forget about the other radical, so I need to also do restrictions for that one. So 2n minus 1, that has to be greater than or equal to 0. Add 1 onto both sides, so the 1's would cancel, and then we just get a 1 here. And then divide both sides by a 2, and so I get n is greater than or equal to 1 over 2. Now looking at these two restrictions, I'm going to explain why one of them is actually redundant and we don't need to actually state it. So if we had these two numbers on a number line, negative 5 over 4 is less than a half, so it's got to be on the left on a number line. And if we look at this inequality, it said n is greater than or equal to negative 5 over 4. So our number n, it has to be greater than or equal to negative 5 over 4. So it'd be an arrow going to the right. With this second one, n is greater than or equal to a half, we'd have to start at a half, and then we are greater than or equal to that one as well. So you can see there's only one region where both of them overlap, and that is in this region right here. So this one, where this is, that we don't need because it has to be true for both of these. So we only are wanting this region right here, and that is this inequality. So what I can do is I'm actually going to unbox this one right here, and this one down here is the only one that we need to box as a restriction because it contains both of them within the one restriction. So I'm just going to erase this now so we can solve this. So our second step was to put one radical on each side. So I need to get this one over to the other side. So when that moves over, it's going to now change that minus. It's going to be a plus. So I'm going to have this one on this side. And then equals. And then when that one moves over, it's now positive. And then don't forget that we had a 2 over here. So we got a plus 2 still hanging there. Now what we need to do is we need to square both sides to get rid of the square roots. So the square and the square root are going to cancel there. Now what you cannot do on this right side, you can't just apply the 2 to that square root and then apply this exponent of 2 to this 2. That would be incorrect. What you need to do is you need to write that out twice, because that's what squaring means. It means multiply it by itself. So I'm going to have 2n minus 1 in a square root plus 2 times itself like this. And then on the other side, that canceled out, and we just have 4n plus 5. So we got kind of a mess here that we're going to need to FOIL and see what we get. So the left is just going to stay the same. On the right side, we're going to have a root 2n minus 1 times a root 2n minus 1, and that just equals 2n minus 1. The square roots cancel out. So we've done that one. Then we're going to have this multiplication, root 2n times a 2, so that's a plus 2 square root 2n minus 1. Then we have this one right here, so that's another one of those, a 2 times a square root 2n minus 1. And then lastly, I got a 2 times a 2, and that's just 4. So we'll keep this 4n plus 5 the way it is on the right, I'm going to write down our 2n, and then I can put the -1 and the +4 together. That's just a +3. And then I can also put these two together. If I got 2 and 2, remember our addition rules, we just add those up. So I have a 4 square root 2n minus 1. And what we want to do now is we want to isolate this radical, get it by itself, and then square it again so we can get rid of the radical. So I'm going to move everything else to the other side. So I'm going to minus 2n minus 2n. Those cancel. I'm going to minus a 3 and minus a 3. So that's going to give me 2n plus 2 equals 4 times the square root of 2n minus 1. So now I've gotten the radical by itself. This 4 I could also divide by a 4, but what that's going to do is it's going to introduce fractions on the other side. So I'm not going to do that. I'm just going to keep the 4 where it is and square it because that's going to be a little bit easier. So I have this, the square and the square root are going to cancel there, but I'm also going to have the 4 being squared. So you just can't forget about the 4 there if you decided to keep it there. So on the left side, when we square that, you're going to have to FOIL it, but what you're going to get is 4n squared plus 8n plus 4. And then on the right, you're going to get 4 squared, that's 16, and then that square root, it canceled out. So we just have 2n minus 1. So now that we got that, we can simplify this right side. We can multiply the 16 into the brackets. So I'm going to have 32n minus 16. Our left side is just going to stay the way it is. And then what I can do is move everything all onto one side. So I'm going to minus 32n from both sides. And then I'm also going to add 16 onto both sides. And then everything on the right is going to cancel, and I'll have everything else on the left side here. So we finally narrowed it down to this. We're getting near the end. What I'm going to do here first is I'm going to divide both sides by a 4. So every term gets divided by 4. So this is divided by 4, this is divided by 4, everything is being divided by 4. And you can only do that with equations. You can't do that with expressions. So I'm going to get n squared minus 6n plus 5 equals 0. And now what I can do is my product and my sum. So my product is 5 and my sum is negative 6. And then the two numbers that multiply to 5 and sum to negative 6 is negative 5 and negative 1. So it's going to break apart into those two factors, n minus 5 and n minus 1 equals 0. And then take each of those, set them equal to 0, and you're going to get n equals 5 and n equals 1. And then when you go to verify your answers, both of these actually work. So both of them still remain answers. Okay, so that was a long one. Just don't forget when you guys are squaring both sides, first get each radical on one side, because if you have them both on the same side and you try to square it, it's going to be very, very messy and it's going to take way longer to do it. So absolutely do not square something like this off the start. Move it over first. Okay, so that was the last one. We're going to just write down our textbook questions here at the bottom now.